15 seconds. That is how long you would stay conscious if you stepped onto Titan right now, with no gear, no suit at all. Not because the atmosphere would crush you. It would not. Not because the pressure would boil the blood in your veins. It will not. Titan's air is actually thicker than the air you are breathing right now on Earth. Roughly the weight you would feel swimming 50 feet beneath the surface of the ocean. You would not need a pressure suit at all. That is the thing almost nobody tells you. Titan is the only place in the entire solar system, besides Earth itself, where the atmosphere alone will not kill you. What will kill you is the cold. Nearly 290 degrees below zero on the Fahrenheit scale. Close enough to liquid nitrogen that any exposed skin would begin destroying itself within seconds. And there is no oxygen. None at all. 15 seconds of consciousness. 2 minutes to death. But here is where this becomes strange. Add a breathing mask and the right thermal suit, the kind of gear a polar researcher already carries into the field, and suddenly you are not dying in 2 minutes. You are surviving. Perhaps for hours. Perhaps far longer. Perhaps, if we are being serious about the engineering, indefinitely. So let us be serious. How long could a human actually survive on Titan? And what would it take to get there? Consider the world you would be standing on. Titan is not a small place. It is the second largest moon in our entire solar system, and it is wider across than the planet Mercury. If it orbited the Sun on its own, we would call it a planet without a moment's hesitation. It is a genuine world, with weather, with seasons, with rivers and seas and falling rain, and nearly every part of it is quietly trying to end you. The light there is roughly 1,000 times dimmer than the noon sun you know, a permanent orange dusk that never once brightens into day. The sky is not blue, it is the colour of old rust, a thick standing haze that the distant sun can barely push its way through. Rain falls there, but it is not water. The seas shine like polished glass, but you could not drink a single drop. Everything about that surface is familiar in its shape and utterly foreign in its substance. And this is the contradiction sitting at the very heart of the question. Titan is one of the most lethal surfaces a human being could ever choose to stand upon. And yet it may also be the single most reachable one, not because it is gentle. It is not gentle. But because the one force that makes every other alien world instantly, violently fatal, the raw pressure of the air pressing in, or the vacuum tearing out, is the one force Titan simply hands to you for free. Here is what most people get wrong. We imagine survival on an alien world as a battle against being crushed, against being torn apart, against a vacuum straining to pull us inside out. On Titan, that particular battle never happens. The threat there is quieter than that, and stranger, and it changes everything about what a human would truly need in order to live. If you find a slow, careful journey through the real science of another world calming, the kind of deep dive you can simply sink into and let carry you along, do me a small favour and press the like button and subscribe. It genuinely helps this channel grow, and it lets me keep making these long, unhurried journeys for you. Now settle in. Make yourself warm and comfortable. Somewhere the cold of this particular world can never quite reach you. We are about to spend the next long while standing together on the surface of Titan and working out, piece by careful piece, exactly how long a person could last there and what it would cost to stay. Let's begin. To understand how long a person could survive standing on the surface of Titan, you first have to understand how astonishingly long it took us simply to learn that Titan was there at all. The world we are about to stand on was, for almost the entire span of human history, not even a rumour. It was a single unremarkable point of light, drowning in the glare of the ringed planet it circles. Nobody knew it was a place. Nobody suspected there was a surface to stand on, or an atmosphere to breathe, or a reason at all to ask the question we are asking tonight. The first human being to see it lived more than 3.5 centuries ago. In the year 1655, a Dutch astronomer named Christiaan Huygens, working from the city of The Hague, turned a telescope of his own careful design towards Saturn. He was not hunting for a moon. He was studying the strange handles that earlier observers had sketched around the planet, the puzzling features that would one day resolve into rings. But there beside Saturn, he noticed a faint companion, a steady dot that travelled with the planet from night to night. He had found the largest moon in the outer solar system. He did not know that. He could not possibly have known that. To him it was simply a fifth wanderer near Saturn, a fleck of light no wider than a thought. What Huygens had actually found would take another 300 years to reveal itself. That dot is a world, not a small one either. Its radius is roughly 2,574 kilometers, which makes it larger across than the planet Mercury, and the second largest moon anywhere in the solar system, surpassed only by Ganymede. If you could lift Titan out of its orbit and set it adrift among the Sun's planets, it would hold its own as a genuine world in its own right. Yet from a rooftop in The Hague, in 1655, it was nothing more than a pinprick, utterly indistinguishable from a distant star. For the next 289 years, that pinprick kept its secrets. Astronomers gave it a name. They called it Titan, after the elder giants of old myth, the generation said to have come before the gods. They tracked its slow orbit. They measured its faint brightness. But they had no way to know what it was made of, or whether it possessed any solid surface at all. The telescopes of the 17th, the 18th, and the 19th centuries could magnify that dot again and again, but they could never truly open it. It stayed a closed door, a world sealed against every eye that looked at it. The door began to open in the year 1944 at the McDonald Observatory, high in the mountains of West Texas. An astronomer named Gerard Kuiper aimed a spectroscope at Titan and did something no one before him had managed. He took the moon's light apart. When you spread a world's light into its separate colours, the dark gaps and bands within that spectrum quietly announce which gases are present, because every gas drinks in light at its own particular wavelengths. Kuiper was reading a chemical signature written entirely in shadow, and in Titan's thin borrowed light, he found the unmistakable fingerprint of methane. This was not a minor footnote. It was the first hard proof that Titan possessed an atmosphere at all. Not a faint trace of gas clinging to a dead ball of rock, but a real envelope of air, thick enough to leave its mark on light that had crossed more than 1 billion kilometers to reach a mountaintop in Texas. Titan was, and still is, the only moon known to wrap itself in a substantial atmosphere. In that single quiet measurement, the dot stopped being a rock and became a world with weather. That atmosphere, we now understand, is enormous. It rises roughly 600 kilometers above the surface, nearly 10 times the height of the delicate layer of air that wraps our own planet. It is so deep and so heavy with haze that it does something almost contradictory. It throws a great deal of the feeble sunlight that reaches it straight back into space, which keeps the surface far dimmer and far stranger than it would otherwise be. And the sunlight arriving there is feeble indeed. Titan orbits Saturn, and Saturn drifts through the dark roughly 10 times farther from the Sun than Earth does. The light that falls on Titan is about 100 times fainter than the light of a bright afternoon at home. Consider for a moment what that distance means for something as simple as a beam of light. Sunlight reaches the Earth in about 8 minutes. That same beam, continuing patiently outward, does not arrive at Titan for roughly 80 minutes more. The sun that hangs over Titan is not the sun we know. It is a smaller, colder lamp, an hour and a half away even at the speed of light, a bright coin pinned to a sky the colour of rust. For everything Kuiper had learned, Titan remained a face behind a veil. Knowing a world has an atmosphere is not at all the same as seeing its surface, and Titan's atmosphere, as it happened, would guard that surface jealously. The proof of that arrived in the year 1980. In November of that year, a spacecraft called Voyager 1, in the middle of its long grand tour of the outer planets, swept close to Titan and turned its cameras hopefully toward the ground below. It saw nothing. Not a mountain, not a sea, not a single feature of the world beneath. What Voyager 1 captured was a smooth, blank, featureless ball of orange haze, an unbroken shell of smog that hid absolutely everything below it. The most advanced cameras humanity had ever flung into deep space, arriving after years of travel, sent home a portrait of a plain orange marble. It was one of the great anticlimaxes in the history of planetary exploration. And in the very same instant, it was one of the great provocations, because now we knew beyond any doubt that a surface was down there. We simply could not lay eyes on it. The orange, we would eventually learn, comes from tholins. These are complex organic molecules, forged high in the upper atmosphere, when sunlight and energetic particles tear apart methane and nitrogen, and allow the broken fragments to knit themselves back together into heavier compounds. These haze particles drift in the high air and scatter away the blue, the violet, and the ultraviolet light, while permitting the longer red and orange wavelengths to filter through. The result is a sky that is not blue and not black, but a deep and uniform amber, a permanent sunless dusk hanging over the whole of the world. So if we ever wanted to see beneath that veil, we would have to go there ourselves. And more than that, we would have to bring something that could fall all the way through the haze and come to rest on the ground. That was the audacious idea behind the most ambitious mission ever aimed at the outer solar system. On the 15th of October, 1997, a spacecraft named Cassini lifted off from Earth, carrying a small European probe bolted firmly to its flank. That probe was named Huygens, in honor of the man who had first glimpsed this point of light 342 years before. The journey was not quick. Nothing about reaching Saturn is ever quick. Cassini did not fly in anything like a straight line, because no rocket humanity has ever built could carry enough fuel to simply cross that gulf directly. Instead, the spacecraft wound its way through the inner solar system, stealing a little speed from the planets it passed, borrowing a measure of momentum from each world in turn, gathering the velocity it needed one gravitational nudge at a time. It fell through the dark for 6 years and 8.5 months before Cassini finally settled into orbit around Saturn on the 1st of July 2004. 7 years, very nearly, just to cross the distance. And even then, the most important part of the entire mission had not yet begun. The Huygens probe waited on, still clamped to the side of its mothership, while controllers back home chose exactly the right moment to release it. When that moment came, Cassini let it go. Huygens drifted free, silent and unpowered, coasting toward Titan as a dead weight, aimed at a target it had no way to steer toward. It could not correct its course. It could not slow itself. It could only fall, the way a stone falls, along the line it had been given. And on the 14th of January, 2005, after 350 years of patient human looking, and 7 years of patient human travel, that small probe struck the very top of Titan's atmosphere and began the descent that everything before it had been building toward. Every telescope raised in The Hague, every spectrum split apart in Texas, every blank orange photograph from Voyager 1, all of it had been leading, across 3.5 centuries, to a single fall through a single alien sky, and the fall itself would not be gentle, or brief, or without cost, because for all our patience and all our engineering, we were about to learn just how little Titan intended to surrender, and just how narrow the window truly was. The descent lasted 2 hours and 30 minutes. That number deserves a moment of its own, because it is far longer than most people picture when they imagine a probe reaching the ground. 2 hours and 30 minutes is the length of a feature film. It is a slow afternoon. It is time enough to grow bored, if a machine could grow bored, drifting down through layer after layer of an atmosphere no human eye had ever seen from the inside. And Huygens spent every second of it working. As the first parachute snapped open high in the haze, the probe began to taste the alien air through its instruments, sampling, measuring, listening. It was not falling blindly. Not anymore. It was falling and reporting, sentence by sentence, in a language of numbers beamed upward to Cassini as it passed overhead. What those numbers described was a world of layered wind. High up, around 150 kilometers above the surface, the atmosphere was moving with astonishing violence, streaming past at more than 400 kilometers per hour. This was not a place a body could hang quietly. The probe was seized by those upper winds and carried sideways as it sank, drifting across the very sky it was trying to measure. But here is the first of Titan's quiet contradictions. As Huygens descended, the wind did not grow stronger the way intuition insists it should. It grew gentler. Lower and lower, the great streaming rivers of air thinned to a whisper, until at the surface itself the wind had all but died. Down where the ground waited, the air was barely moving at all, only a few meters per second, a breath you could almost stand against. Not a gale, not a storm, a stillness at the bottom of a screaming sky. Then the ground arrived. On the 14th of January 2005, after 2.5 hours of falling, Huygens touched the surface of Titan. It did not crash, and it did not settle softly onto stone. It struck something stranger than either. The impact drove the probe roughly 12 centimeters into the ground, carving a small crater, and then the probe slid forward another 30 to 40 centimeters before coming to rest. And even then it was not quite still. It wobbled. 5 separate times, over roughly 10 seconds, the probe rocked and rebalanced before finally going quiet. From that gentle violence, that skid and shudder and settling, scientists could read the texture of a world. The surface of Titan, they concluded, had the consistency of loose wet sand. Not sand as a desert knows it, not the mineral grit of Earth. This was a crust of dirty water ice, pebbles of frozen water darkened by organic residue, packed together with something soft and yielding beneath. A beach, in a sense. A beach at nearly 291 degrees below zero, where the water is stone and the sand is ice. And having landed, Huygens did something no machine had ever done in that part of the solar system. It survived. It kept working on the surface of an alien moon for 54 minutes. 54 minutes. Not 54 hours, not 54 days. Less time than it takes to watch a single episode of television. That is the entire duration of humanity's direct, on-the-ground presence in the outer solar system. Everything we have ever measured from the surface of a world beyond the asteroid belt, we measured in those 54 minutes. The probe was never designed for more. It ran on batteries, and it went cold, and eventually Cassini sailed beyond the horizon and could no longer hear it. But for those 54 minutes, we were there. Not looking through a telescope, not guessing from a spectrum, there, on the ground, in the orange light. Even that triumph carried a wound. Huygens had been built to send home 700 images. It sent 350. Half of the pictures, half of humanity's first and only photo album of the surface of Titan, was simply lost. The cause was almost embarrassingly small. Cassini, the mothership listening overhead, received the probe's data on 2 separate channels, called Channel A and Channel B, for redundancy, so that if one failed the other would carry the load. But a command to switch on the receiver for Channel A was never sent. The channel that was supposed to be the safety net never woke up, and so every image routed through it vanished, unrecorded, unrecoverable. Not lost to distance, not lost to the cold, lost to a single instruction that was never given. 350 photographs reached Earth. 350 more had existed, briefly, as radio signals rising from the probe toward a ship that was not listening on that channel. And then they were gone. But the 350 that survived were enough to overturn everything. Because when the descent imager aboard Huygens finally measured the light on Titan's surface, it confirmed something the haze had only hinted at from orbit. The world down there is dark. Profoundly, permanently dark, though not in the way of night. The illumination at Titan's surface is roughly 1,000 times dimmer than the full sunlight that falls on Earth at noon. Imagine the brightest, clearest afternoon you have ever stood in, and then imagine that light drained away until only 1,000th of it remained. That is high noon on Titan. It is not blackness. It is a deep, uniform amber gloom, the light of a heavily overcast dusk that never lifts and never falls, holding steady across a day that lasts nearly 16 of ours. And the colour of that gloom is the strangest detail of all. The sky of Titan is not blue, and it is not black. It is orange, a dull, rusted, uniform orange, the colour of old brass or weak tea or a horizon choked with distant smoke. The reason lies in the haze itself, in the particles that fill Titan's upper air, cold tholins. Tholins are not simple dust. They are complex organic molecules, tangled chains of carbon and nitrogen and hydrogen, built by sunlight tearing apart the methane high in the atmosphere and letting the fragments recombine into something heavier and darker. These particles hang in vast suspended layers, and they are selective about the light they permit to pass. They scatter and absorb the blue and the ultraviolet, the shorter wavelengths, stripping them out of the sunlight before it ever reaches the ground. What survives the journey down is the red and the orange, the longer, warmer wavelengths that slip through the haze unbothered. So the light that finally lands on those icy pebbles has already been filtered, already been robbed of half its spectrum. You would not see the world in true colour. You would see it the way the tholins allow, drowned in perpetual amber. Consider what that means. For 350 years we looked at Titan and saw only a smooth, featureless dot, a blank orange marble, because the very haze that hid the surface from Christian Huygens and Gerard Kuiper and the cameras of Voyager 1 is the same haze that paints the surface orange from below. The thing that blinded us from the outside is the thing that colours the sky from the inside. It is the same veil, seen from two sides. And it took 3.5 centuries of looking, 7 years of falling, and 54 minutes on the ground to finally stand beneath it and begin to understand. This is the crushing truth the grounding leaves us with. We have visited Titan exactly once, for less than an hour, with a machine that could not breathe, could not move, and lost half of what it saw. Everything else we believe about surviving on that surface, every scenario that follows, every minute and every death we are about to count, rests on those 54 fragile minutes and the fragments of light they sent home. We know just enough about Titan to know exactly how it would kill us. So let us count the ways. There are, when everything else is stripped away, only 3 facts about Titan that matter to a human body standing bare on its surface. The pressure, the air, the cold. Every question of survival begins with these 3 and ends with them, and the order in which they kill you is not the order you would guess. Most people, asked what would happen to a person set down without protection on that orange ground, reach instinctively for one of 2 mental pictures. Both of those pictures are wrong. Not slightly wrong, fundamentally wrong. The first picture is violence. It is the picture of a body destroyed by pressure, either bursting outward into the thin nothing of an alien sky, or crushed inward like a submarine hull past its rated depth. It feels correct, because we have been trained by 100 films and 1,000 documentaries to believe that any world not our own must annihilate the unprotected body in some spectacular, immediate way. And on almost every other surface in the solar system, that training is accurate. On the Moon, on Mars, on the airless plains of Mercury, the near vacuum outside would pull at your lungs and your blood and your soft tissues with a force your body was never built to resist. But Titan is not almost every other surface. Titan is the exception. Titan is the one place that breaks the rule. Consider what the Huygens probe measured in the moment it came to rest. On the 14th of January, 2005, its instruments read a surface pressure of 1,467.6 millibars. On Earth, at the shore of any ocean, the air presses down at roughly 1,013 millibars. So the air on Titan does not press less than the air you are breathing right now. It presses more, roughly 45% more. To feel it, you would not climb a mountain or step into a vacuum chamber. You would swim down, 50 feet down, into the green quiet of a lake or a sea, until the water above you weighed on your ears and your chest, with exactly the firmness that Titan's atmosphere would rest against your skin. That is the sensation, not the terror of the void, the gentle, familiar heaviness of being 50 feet underwater. This is the first thing most people get wrong, and it is worth sitting with, because it inverts everything. A scuba diver descends to that depth and beyond without a rigid suit, without a pressure vessel, without any protection but a thin layer of neoprene and a tank of gas. Divers work comfortably at 2 and 3 atmospheres of pressure for hours at a time. Titan's surface sits at barely 1.5. So the pressure on Titan is not the thing that would kill you. It is not even a serious inconvenience. It is, of the 3 great facts, the one mercy. Not because Titan is kind. Titan is not kind. But because in this single respect, and only this one, the physics happen to land on the side of the fragile human body. Now the second picture. The second picture is ice. It is the cartoon image of a person turned instantly to a frosted statue, frozen mid-step, shattering like glass on the ground. And here the popular imagination is closer to the truth, because Titan is monstrously, unspeakably cold. But even this picture is wrong in a way that matters, because it gets the timing exactly backward. The cold is real. The cold is one of the 2 true killers. But the cold is not the first to reach you. Something quieter, something invisible, something you cannot see or feel or smell, gets there first. That something is the air itself, and what the air does not contain. Titan's lower atmosphere is roughly 95% nitrogen and roughly 5% methane. Read those 2 numbers again and notice what is missing. There is no third number. There is no slice of that atmosphere set aside for oxygen. Not a trace. Not a whisper. The gas that fills every breath you have ever taken, the gas your brain consumes at a rate it cannot pause or ration, simply does not exist on the surface of Titan in any free form at all. And so the first thing that would happen to an unprotected human on Titan is the same thing that would happen to an unprotected human in the vacuum of deep space, or at the bottom of a sealed tank of pure nitrogen here on Earth. Nothing. For a breath or 2. Then the lights begin to go out. The timeline is brutally short and disturbingly well understood. Within roughly 15 to 20 seconds, the oxygen already dissolved in your blood is spent. The supply to your brain fails, and consciousness ends. Not slowly, not with a struggle. The cruelty of oxygen starvation by inert gas is that it arrives without the alarm of suffocation, because the body's panic response is triggered by rising carbon dioxide, not by falling oxygen. And in an atmosphere like Titan's, the carbon dioxide simply washes away with each exhale. You would not claw at your throat. You would not feel the drowning terror of held breath. You would feel, if anything, a strange lightness, a warmth, a fading. And then you would be gone. Unconscious in under 20 seconds. Dead within about 2 minutes. This is the same window, almost to the second, that the human body faces when exposed to hard vacuum, which is a quiet and remarkable fact. The emptiest place imaginable, and the thick nitrogen air of Titan kill a person on precisely the same clock. No one has ever measured this on Titan, of course, and no one ever should. It is inference, drawn from what we know of the body and what we know of the air. But it is inference of the most confident kind, the kind built from a century of understanding how a brain deprived of oxygen behaves. The honest answer is that the exact number of seconds would vary from one person to the next. The honest answer is also that the difference between 15 seconds and 20 hardly matters when the destination is the same. So the air wins the race, but it wins by less than 2 minutes, and in that narrow margin the cold is already at work. And the cold is the more visceral horror by far, because oxygen starvation is gentle in its way, a fading of the light. The cold is not gentle, the cold is a wound. Titan's surface holds at about 179 degrees below zero on the Celsius scale, which is roughly 290 degrees below zero on the Fahrenheit scale. To grasp what that number does to living tissue, you do not need to imagine anything exotic. You need only think of liquid nitrogen, the pale fuming liquid handled in laboratories and hospitals across the world, the fluid used to burn away warts and freeze biological samples solid. Liquid nitrogen boils at about 196 degrees below 0 Celsius. Titan's surface sits within 17 degrees of that, which means the ground you would be standing on, the air moving past your face, is very nearly as cold as the cryogenic fluid that technicians are trained never to let touch bare skin. And what does that fluid do to bare skin? Consider what this means, because it is precise and it is documented. Contact with liquid nitrogen produces what is called a cryogenic burn. The moisture in living tissue freezes in seconds. Ice crystals form inside the cells and tear them apart from within. The skin blisters, whitens and hardens. In severe cases, the damage runs so deep that the tissue cannot be saved, and what was frozen must later be amputated. This is not the slow, creeping frostbite of a winter mountaineer who has time to feel his fingers go numb. This is destruction on the scale of seconds. Any exposed skin on Titan, a cheek, a wrist, the back of a hand, would not merely feel cold. It would begin to crystallize, to harden into something that no longer bends and no longer heals. And there is one final cruelty layered on top. The Huygens probe measured the winds at the surface and found them gentle, only a few meters per second, little more than a slow walk. On Earth we would call that a mild breeze, almost nothing. But wind chill does not care how mild a breeze feels at a comfortable temperature. At 179 degrees below zero, even a slow drift of nitrogen air strips heat from a surface faster than still air could, driving the cold deeper and quicker into whatever it touches. So the cold does not wait patiently for the still moments. The faint breath of Titan's wind carries it to you. Here, then, is the true anatomy of dying on Titan, stripped of the two false pictures. You would not burst. You would not implode. The pressure, the thing everyone fears first, is the one thing that would leave you entirely alone. Instead, the air would take your mind in under 20 seconds, quietly, almost tenderly, while the cold went to work on your skin like a chemical burn made of nothing but temperature. Two killers, racing. The invisible one wins. The visible one would have won only moments later. And the one force everyone imagines as the executioner turns out to be the only friend you have on the entire surface of that world. Sit with the strangeness of that inversion, because it is the hinge on which everything that follows turns. On Titan, you do not need a pressurized suit. You do not need a rigid shell to hold your body together against the sky. What you need is far simpler to describe and far stranger to contemplate, something to breathe and something to keep you warm. Consider the air first, because the air is the faster of the two killers by a wide margin. Titan's atmosphere is not poison. This is the part that surprises people who imagine some corrosive alien vapor clawing at the lungs, some green gas out of an old horror film. The gas that wraps that entire moon in its orange shroud is 95% nitrogen, the same inert element that already makes up more than 3/4 of every breath you have ever drawn. You are breathing nitrogen right now, this very second. Your body ignores it entirely, passing it in and out without the faintest flicker of harm. The remaining 5% is methane, and even the methane is not truly what does the damage. Not because methane is gentle in the way nitrogen is, but because the real catastrophe on Titan is not anything the air contains. It is the single thing the air lacks. There is no free oxygen at the surface of Titan. None. Not a trace worth the measuring where a human being would actually stand. And so the manner of your dying there would not be a struggle against something reaching for you. It would be the quiet subtraction of the one thing already missing. Here is the problem, stated as plainly as it can be. Your body cannot store the oxygen it needs. It runs, moment to moment, on a supply that must be constantly renewed, and on Titan that supply simply stops. Consider what this means for the organ that needs it most. The human brain is extravagantly expensive to run. It burns roughly a fifth of all the oxygen the body consumes, while taking up only a small fraction of the body's mass. And it keeps almost nothing in reserve. When the supply is cut, the accounting is swift and merciless. Useful consciousness on Titan's surface would last somewhere between 15 and 20 seconds. Then the lights would begin to dim. To appreciate how strange that number truly is, consider that it is the very same window a body would have in the hard vacuum of open space, where there is no air at all. Titan surrounds you with an atmosphere thick enough to swim through, and it buys you nothing. 15 to 20 seconds to unconsciousness. Death within roughly 2 minutes. A moon, drowning in air, and a human being suffocating in the middle of all of it. This is the cruelty folded inside the mercy. Not an absence of atmosphere at all, but an overwhelming abundance of exactly the wrong one. 2 minutes. Consider that against the ordinary arithmetic of a human life. It is less time than it takes to boil an egg, less time than a single song, less time than you have already spent listening to this description of the place. In that same brief span, a person set down bare upon Titan would pass from standing and aware to gone, and the world around them would not so much as register the difference. The orange haze would hang exactly as it did. Nothing in that patient landscape would mark the moment. There is a further strangeness to that air worth holding for a moment. Near the surface, the methane hangs at roughly half its saturation point, which on Earth we would simply call 50% humidity. Except the humidity here is not water, it is methane, thick enough to drift as a faint cold fog across the ground. You would be standing inside a mist that could never be rain the way you know rain, breathing through equipment while a fuel you could never light without oxygen curled around your boots. Now turn to the second need, the one that would go on working long after your mind had already gone dark. Warmth. Or rather, the total and unrelenting absence of it. When the Huygens probe settled onto the surface on the 14th of January 2005, at 43 minutes past noon in Coordinated Universal Time, its instruments read a surface temperature of 93.8 Kelvin, translated into the scale that lives in the human body. That is very close to 291 degrees below zero on the Fahrenheit scale, or 179 degrees below zero on the Celsius scale. Numbers that extreme stop carrying meaning on their own, so anchor it to something a chemist would recognize on sight. Liquid nitrogen, the pale fuming liquid poured from insulated flasks in laboratories all across the Earth, boils at a temperature only about 17 degrees colder than the ground where Huygens came to rest. Stand on Titan, and you are standing in a place very nearly as cold as liquid nitrogen itself. Not metaphorically cold, not poetically cold, cold in the literal chemical laboratory sense of the word. Everyone has seen the film of a flower dipped into a flask of liquid nitrogen. It stiffens in a few seconds, and then shatters like thin glass the instant it strikes the bench. Living tissue behaves no differently. Contact with a surface at this temperature does not bring the slow, dull ache of ordinary frostbite. It brings a cryogenic burn, the water inside your cells freezing and expanding until the cells themselves rupture, skin blistering and blackening. The damage in the worst recorded laboratory accidents so severe that the only remedy left is amputation. And that is from a splash that lasts a single second. Titan offers no single second. The cold is everywhere, constant, patient, pressing against every exposed inch of you all at once. You would feel it, and then, very quickly, you would feel nothing there at all. The wind would only quicken the work. Huygens measured no gale at the surface, only the gentlest movement of air, a few meters per second, little more than the pace of a slow walk. On a warm evening on Earth, that would be a kindness, a breeze you would turn your face into. At 179 below, That same faint stirring strips warmth from anything it touches faster than still air ever could, dragging the heat out of a body and carrying it away into a sky that will never return it. And through the whole of it, the pressure remains your one improbable ally. The weight of Titan's atmosphere at the surface measures a little over 1/4500ths of Earth's sea level pressure, roughly 45% greater than the air in the room around you. That is not a crushing force. It is very nearly the pressure a diver feels at a depth of about 15 meters, some 50 feet beneath the surface of the sea. Divers sink to that depth every single day, linger there among the fish, and rise again completely unharmed. Not a force that would break your body, but a force so unremarkable that a swimmer meets it on a shallow afternoon and never gives it a second thought. This is what sets Titan apart from everywhere else a human might ever stand. On the Moon, on Mars, on every airless rock and thin-skinned world we have ever charted, the vacuum, or the near vacuum, tears at a body, pulling dissolved gases out of the blood, demanding a rigid pressurized shell simply to hold a person in their ordinary shape. Titan demands none of that. It is the only surface in the entire solar system, save the Earth beneath your own feet, where the pressure alone would leave an unsuited human whole. You would need no armor against the sky. You would need only the two humble things any mountaineer already carries in spirit: air to breathe and heat to keep. And that quietly rewrites the entire question. Surviving on Titan is not a matter of holding back a hostile world by force. It is a smaller, gentler, far more solvable kind of problem. Give a body oxygen, give it warmth, and Titan stops being an executioner and becomes merely a place. A cold place, a dim place, a patient place. But a place where a living person could stand and turn slowly around and look. What remains is only to ask how much air and how much warmth, and above all, for how long. And the answer to that, layer by careful layer, is stranger and more hopeful than that frozen surface would ever lead you to believe. So let us build that answer the way a careful engineer would build a machine, adding one component at a time and watching what each addition buys. Begin with nothing. Begin with a person standing on the loose, wet sand of that landing site, wearing only the clothes they woke in that morning, carrying no equipment of any kind. This is the ground floor of the ladder. It is worth pausing here, because everything that follows is measured against this single unprotected body. If a bare human were set down on Titan's surface with no protection whatsoever, the first thing to fail would not be the skin, it would be the breath. The air is 95% nitrogen and 5% methane, and it holds no free oxygen at all. Not a trace. The lungs would draw it in eagerly, expecting the same mixture they have taken every second since birth, and they would find nothing there to keep the body alive. Consciousness would not fade gently. It would switch off in 15 to 20 seconds, the same neurological window that closes on a body exposed to the vacuum of open space. Within roughly 2 minutes, the person would be dead, not from the cold, not from the pressure, from the simple absence of a single element. That is the strange cruelty of the ground floor. The cold, which is the thing you would fear most, never even gets its turn. It stands in line behind the suffocation, waiting for a body that has already stopped moving. The temperature outside is 179 degrees below zero on the Celsius scale, roughly 290 degrees below zero on the Fahrenheit scale, and that cold is patient enough to fracture living tissue. But asphyxiation is faster. Here is the first lesson of the ladder. The first killer on Titan is not the ice, it is the emptiness in the air. So we add the first component. Give the person a breathing apparatus, a mask and a tank of oxygen, the kind a firefighter carries into a burning building, or a diver carries beneath the sea. Nothing else. No suit, no insulation, only air. Now ask what that single addition buys. It buys a change in how you die, and very little more. With oxygen flowing steadily, The 15-second clock stops. The lungs are satisfied, but the cold, which had been waiting so patiently, finally steps forward to take its turn. And here the comparison that should settle into your mind is liquid nitrogen. Liquid nitrogen boils at 196 degrees below zero Celsius. Titan's surface sits at 179 below. The gap between them is only 17 degrees. For the purposes of a human body, Titan's surface is very nearly as cold as an open bath of liquid nitrogen. We know precisely what liquid nitrogen does to living tissue, because it happens in laboratories all the time. A splash on bare skin produces a cryogenic burn within seconds, blistering, the destruction of cells, damage so deep that in the worst cases the affected limb must be amputated. On Titan, any exposed skin would begin to crystallize on the same timescale. The water still held in the surface layers of the flesh would freeze and expand, and the delicate scaffolding of the cells would rupture from within. This is not the slow numbing of a cold winter walk. It is tissue destruction measured in heartbeats. And there is a quiet accomplice to the cold. Even at the landing site, where the winds were gentle, only a few meters per second at ground level, that faint moving air would strip heat from an exposed body far faster than still air ever could. On Earth we call this wind chill, and we treat it as a modifier, a few degrees stolen from an already cold day. On Titan the baseline is so far below the freezing point of flesh that even a slow breeze becomes an active hand pulling warmth out of you. The oxygen mask keeps the lungs alive while the skin surrenders. This is the second rung, and it teaches the second lesson. Air alone is not survival. It is only a slower kind of dying. So we add the second component, and here the ladder begins to climb in earnest. Take that same person, still breathing bottled oxygen, and dress them now in the finest cold weather clothing a mountaineer might carry toward the highest summits on Earth. Layered insulation, a sealed outer shell, gloves and boots and a hood. Everything engineered to trap body heat against the killing chill of altitude. On the coldest peaks of our own planet, gear like this holds a climber alive through nights that fall to 40 or 50 degrees below zero. It is a genuine achievement of materials and design, and on Titan, it would buy minutes, perhaps a few tens of minutes, if the person stood still and did nothing to spend their warmth. But no more than that. Because the clothing that keeps a mountaineer alive was built to fight a cold, measured in tens of degrees below zero, and Titan asks it to fight a cold nearly 4 times deeper. Heat does not care about intentions. It flows from the warm thing to the cold thing, always, and the steeper the difference between them, the faster it flows. A human body is a small furnace, producing something like the warmth of a dim light bulb, and Titan is an ocean of cold, with no bottom and no shore. The insulation slows the loss. It cannot stop it. The core temperature would begin its slow, fatal slide, and consciousness would fade not in seconds now, but in the quiet accumulation of minutes. Yet notice what has happened as we climbed these 3 rungs. We began with 15 seconds. We have reached tens of minutes, and nothing we have added is exotic. A tank of oxygen. A well-made coat. These are things that already exist. Things a person could carry today. Consider what this means. The distance between instant death and a survivable half hour on the surface of a moon, nearly 900 million miles from the sun, is not some undiscovered technology. It is equipment you could buy. The gap that remains is not a gap in what is possible. It is only a gap in degree, and Titan strangely helps you close it. On the surface, gravity pulls at only 135 thousandths of the force it exerts on Earth, roughly 1/7 of your home weight. A suit that would crush you with its mass on a planetary surface becomes almost weightless here. Every kilogram of insulation you might want to add, every extra layer, every heavier and more capable shell, costs you 1/7 of the burden it would on Earth, or even on Mars. The very world trying to freeze you also lightens the armor you carry against it. You could wear more, far more, and still walk upright across the sand, still lift your arms, still turn to look at the orange sky. The low gravity is not a hazard here. It is a gift handed to the engineer. There is another gift hidden in that lifeless air, and it is easy to miss. On Earth, a person surrounded by 5% methane and carrying a tank of pure oxygen would be standing inside a bomb. Methane is fuel. Oxygen is the thing that lets fuel burn. Bring the two together with a single spark and you have an explosion. But Titan's atmosphere holds no free oxygen at all, and without an oxidizer, methane cannot ignite. It simply cannot catch. The methane seas could sit beside you, the methane in the air could swirl around you, and none of it would burn, because the one ingredient a fire requires is the very thing your body brought with it and keeps sealed inside the tank. On Titan, the fuel is everywhere and the flame is impossible. It is one more way that this world inverts the dangers we think we understand. So we keep climbing. Add now the third component, not a mountaineer's coat, but a purpose-built suit of the kind militaries develop for their coldest operations. Engineered garments rated to hold a soldier alive at 60 degrees below 0 Celsius, for hours at a time. Heated elements woven through the layers. Sealed seams. Active systems that fight the cold rather than merely resisting it. This is no longer clothing. It is a small machine wrapped around a body, and it changes the arithmetic again. With a suit like this, and oxygen to breathe, the tens of minutes stretch toward hours. A person could stand on Titan through a span longer than the 54 minutes that the Huygens probe itself endured on that same frozen ground before its voice fell silent forever. They could walk, they could kneel and press a gloved hand into the dirty water as pebbles. They could watch the dim orange light, 1,000 times fainter than an earthly noon, lie flat and shadowless across the dunes. And they could do all of it while the cold pressed in from every side, held back not by hope but by engineering. But here is the problem, and it is the same problem that has followed us up every rung. Even a suit rated to 60 below 0 is fighting a world at 179 below. It buys hours. It does not buy safety. The cold outside is still nearly 3 times deeper than the coldest condition the suit was ever designed to face. And heat, that patient thief, is still flowing outward through every seam and every joint. The suit is winning the argument for now. It is not winning it forever. And so the question that began this climb sharpens into something more precise. The question is no longer whether a human being could survive on Titan at all. We have already answered that. The question is how far this ladder can be made to climb, and what it would take to build a rung high enough that the cold, at last, stops mattering. To build that rung, you have to stop thinking like a mountaineer and start thinking like an engineer of extremes. The clothing that keeps people alive in our planet's coldest places works by trapping warm air against the skin, layer upon layer of stillness holding the heat you generate close to your body. On Titan, that entire strategy collapses at the first seam. There is no warm air to trap, and the world outside is hungry for every last calorie your body can make. So the engineer abandons the idea of merely slowing the loss of heat and reaches instead for something far more aggressive. Not a coat, but a furnace worn against the skin. Picture the architecture of such a suit. At its heart sits a power source, most likely a compact nuclear unit from the same family that keeps our deep space probes alive for decades, feeding warmth into a network of heating elements woven through every layer. Around that runs a vacuum-insulated shell, the same principle that keeps a hot drink hot inside a flask, scaled up and wrapped around a living human being, the breathing apparatus we have already established. Oxygen carried on the back, scrubbed and recycled, because the atmosphere all around offers nitrogen and methane in abundance, and not one single molecule the lungs can use. Layer by layer, the impossible gap begins to close. Here is where Titan offers its second mercy, and it is a quiet one. On almost any other world, a suit this elaborate would be impossibly heavy. All those layers, that power plant, those tanks of pressurized oxygen, would drag a person to the ground under their own weight. But Titan's gravity is only about 1/7 of what you feel standing on Earth. A suit that would weigh as much as a grown man on our planet would weigh about as much as a small child out there on the ice. The very engineering that makes survival possible is made bearable by the weakness of the world it defends you from. Not despite Titan, but because of it. Now imagine standing inside that suit, and imagine that it begins to rain. The clouds of Titan hold no water. They are made of methane, and when they release their burden, it falls slowly, gently, in fat droplets that drift down at roughly 1/5 the speed of rain on Earth. It is a rain you could watch descend, each drop taking its unhurried time to reach the ground. And each drop is a thief. Liquid methane at that temperature pulls heat away faster than the still air around it, pressing on the suit's defenses, testing every joint the engineers sealed. The rain does not need to touch your skin to harm you. It only needs to steal warmth from the shell, and it steals patiently. Then there is the wind. At the surface the air barely moves, only a few meters per second, little more than the pace of a slow walk. On a summer evening on Earth you would call it a pleasant breeze. But moving air at 179 below zero is not a breeze. It is a hand that strips heat from every surface it touches, and even a gentle current of air that cold accelerates the outward bleed of warmth through the suit. The reading on the thermometer is only half the danger. Not the temperature alone, but the temperature carried on moving air is what the suit must truly hold back. And there is the matter of seeing where you are going. Near the surface hangs a methane haze, a humidity of roughly 50% that the Huygens probe measured at its landing site. A fog of hydrocarbons thickening an already feeble light. The sunlight that reaches Titan's ground is about 1,000 times dimmer than the noon you know on Earth, filtered through hundreds of kilometers of orange smog until midday feels like the last grey minutes of dusk. To cross this landscape you would move through permanent twilight, and the terrain itself is not gentle. Near the equator, dunes of hydrocarbon sand rise as high as 100 meters, long parallel ridges built by the wind, each one taller than a 30-story building. Not blind, but nearly so, you would climb them in the dark, in a suit that is fighting the cold with every single step. There is one danger Titan cannot pose to you, and it is worth pausing on, because it inverts everything instinct would tell you. On Earth, a suit packed with oxygen tanks, standing in an atmosphere thick with methane, would be a bomb waiting for a spark. Methane is fuel. Oxygen is what allows fuel to burn, but Titan's air holds no free oxygen at all, not a trace, and so the methane that soaks the ground and fills the clouds simply cannot catch fire. The only oxygen for hundreds of millions of miles is the supply strapped to your own back. Fire, that most ancient of human companions against the cold, cannot happen on that surface. Not because the fuel is missing, but because the spark has no partner. So gather all of it together. The furnace suit, the recycled oxygen, the vacuum shell, the low gravity that makes the whole apparatus wearable. How long does that combination buy you? Not seconds. Not the 15 to 20 seconds of a bare and unprotected human. Not the handful of minutes of a climber in ordinary cold weather gear, with active heating and a nuclear heart beating against your spine. Survival is no longer measured against the environment at all. It is measured against your supplies. As long as the power holds and the oxygen lasts, the cold is simply held at arm's length. Days become possible. With resupply, weeks. With a shelter to return to, something that begins to resemble a life. Huygens itself is the proof of the idea, written in metal and left behind on the sand. That small probe, with nothing living aboard it, sat on Titan's frozen surface and kept transmitting for 54 minutes in that murderous cold before its batteries faded and its voice went silent. 54 minutes was never a limit set by Titan. It was a limit set by the battery. Titan did not kill Huygens. Its power ran out, and that one detail reframes the whole question. The cold is not an executioner handing down a fixed sentence. It is a steady, patient pressure that can be resisted for exactly as long as you can keep feeding energy into the thin space between your skin and the dark. Keep paying that price, watt by watt and breath by breath, and the sentence never falls. Stop paying it, and Titan collects in seconds. The cold is not cruel, it is only relentless, and relentless is a thing that engineering knows how to answer, which means the ladder does not end with a rung too high to reach. It ends somewhere far stranger than that. Every scenario we have climbed through has quietly pushed the boundary upward, until the boundary is no longer a wall of physics, but a question of will and supply. Such a suit lies within the theoretical reach of materials we already understand. The nuclear source exists, the insulation exists, the oxygen systems exist. Nothing on this ladder waits on some undiscovered breakthrough, it waits only on a reason to build it. We began by asking whether Titan would kill a human being in seconds, and it would. We end holding a different question altogether, one that has almost nothing to do with survival. Not how long could a human endure Titan, but how long would a human choose to? The equipment can be built, the hours can become days, and so the real question left standing is no longer whether you could stand on that frozen shore and live. It is what you would do once you were there, and what, through the visor of that impossible suit, you would actually see. So grant yourself that suit. Grant yourself the oxygen, the layered insulation, the quiet power source humming against your spine, and a reason good enough to have crossed the 7 years of empty space that separate this frozen shore from home. You are standing now on the surface of Titan, and the first thing you would notice is not the cold, which the suit holds at bay, and not the silence, though it is very nearly total. The first thing you would notice is the light. It is orange, not the orange of a sunset on Earth, which flares and dies within minutes as the sun slips under the horizon. This is a permanent orange. It is a steady amber that fills the entire sky from one edge of the world to the other, the colour of weak tea held up against a lamp, or of old rust, or of honey seen through smoked glass. There is no blue anywhere in it. There is no white. The sun itself, if you could locate it at all, would not appear as a disk, but as a vague brightening somewhere overhead, a smear of pale glow rather than a source you could point to. You would stand in a world with no visible sun and no visible stars. You would stand inside a dome of unbroken orange. The reason for that colour lives in the air far above you. Hundreds of kilometres up, sunlight strikes a thick layer of complex organic particles called tholins, molecules built when nitrogen and methane are torn apart by ultraviolet light and reassembled into long, tangled chains of carbon. These particles scatter away the blue and the violet and the ultraviolet, the short and restless wavelengths, and they allow only the red and the orange to filter down to the ground. It is the very same physics that reddens a sunset in our own sky. Here, though, it never ends. Here the sunset is the permanent condition of the sky, a bruise that does not heal, because the haze that produces it wraps the entire moon in a shell 600 kilometers deep. And it is dim. This is the second thing you would understand, standing there once your eyes had adjusted. The Huygens probe carried an instrument to measure exactly how much light reaches the ground, and its answer was humbling. The surface of Titan receives roughly 1,000 times less light than the surface of the Earth does at noon. Not a little dimmer, 1,000 times dimmer. Imagine the deepest, heaviest overcast afternoon you have ever experienced, the kind of grey day when the streetlights flicker on hours early. Now imagine that same gloom, but tinted entirely orange, and dimmer still. This is not the black of deep space. It is a perpetual coppery twilight, bright enough to read by if you are patient, dark enough that you would never once mistake it for day. Now look down at what you are standing on. Near Titan's equator, where you have chosen to land, the ground is not ice, and it is not rock in any sense you would recognize. It is dune. Vast fields of dunes stretch away in parallel ridges toward the horizon, some of them rising as high as 100 meters, which is more than 300 feet, taller than most of the buildings in a large city. And the sand that forms them is not sand at all. It is made of solid organic grains, dark hydrocarbon particles that the researchers who study them have compared again and again to coffee grounds. You are looking at ridges of frozen chemistry, dunes of soot and tar swept into long, elegant lines by the wind, arranged in the same graceful longitudinal patterns you would find in the great deserts of Earth. Not made of the same material, made of the same shapes. The wind here is patient and slow, but over the ages it has combed these dark grains into the identical forms that Earth's winds carve from ordinary sand. Raise your eyes from the dunes and look toward the horizon, and in some directions you would see something even harder to believe. You would see a shoreline. You would see the edge of a sea. Titan is one of only 2 worlds in the entire solar system with standing bodies of liquid on its surface, and the largest of them is a body called Kraken Mare. It covers roughly 500,000 square kilometers, which makes it larger than the Caspian Sea on Earth, some 5 times the size of Lake Superior. In its central basin it reaches a depth of at least 300 meters, close to 1,000 feet, deep enough to swallow a skyscraper whole. We know this depth not from any boat or diver, but from a spacecraft. On the 21st of August, 2014, the Cassini orbiter swept over that sea during a pass its engineers called the T-104 flyby, firing radar down from an altitude of 970 kilometers while traveling at 21,000 kilometers per hour, and reading the echoes as they returned from the surface and from the floor beneath. But this sea is not water. This is the thing your mind would refuse, at first, to accept. The liquid filling Kraken Mare is methane and ethane, the same compounds that make up natural gas on Earth, chilled so profoundly that they pool as a cold, dark liquid rather than drifting away as vapor. And it does not look like our water. It looks like oil. The surface of these seas is glassy and smooth and faintly reflective, a black mirror lying flat beneath the orange sky, disturbed only by waves that rise and fall in a slow, languid, almost dreamlike motion, far more gently than any wave on any ocean you have known. The low gravity and the thick liquid conspire to make the whole sea move as though filmed at half speed. You would watch a swell cross the surface and feel that time itself had thickened, and these seas breathe with tides. Saturn hangs enormous in the haze above, its vast gravity tugging at Titan just as our moon tugs at our own oceans, and that pull lifts the level of the methane seas by as much as a full meter over the course of a single Titan day. A day here is not a matter of hours. It stretches across nearly 16 of our own days, 15.9 of them to be exact, so the tide does not rush in and out the way it does on an earthly beach. It rises with enormous patience, over the course of what would feel to you like a long and orange week, and then just as slowly, it falls again. There is weather here too, real weather, of a kind that exists nowhere else beyond our own planet. It rains on Titan, not water, but methane, falling from the haze in drops that are larger than Earth's raindrops, and that drift downward at roughly 1/5 the speed, sinking through the dense air with the same unhurried grace as everything else on this world. Near the ground, the Huygens probe measured the methane humidity at around 50%, which means that at the landing site the air was thick with something very close to fog, a cold methane mist hanging low over that strange terrain. Picture standing in a slow drizzle of liquid natural gas, in fog you could not smell through your mask, watching fat droplets fall past your visor as gently as feathers. And here is where everything you thought about this place has to be dismantled and rebuilt. Because if you had pictured Titan before now, you almost certainly pictured it wrong. Most people imagine the outer solar system as a graveyard of dead grey rocks, barren and still and featureless, cratered moons frozen into permanent stillness, worlds where nothing moves, and nothing changes, and nothing ever has. That picture is not merely incomplete, it is fundamentally, profoundly wrong. Titan is not a dead world. It is arguably the most alive alien landscape we have ever laid eyes upon, and its aliveness is precisely what makes it feel, against all reason, like a strange and distant cousin of home. Consider what you are actually surrounded by. You are standing on a beach. There is sand beneath your boots and a sea before you, and a sky above you full of cloud and haze. Rain falls. Rivers over ages have carved channels down toward the shore. Wind builds dunes. Tides rise and fall. Seasons turn across the long Saturnian year. Every single one of these processes exists on Earth, and every single one of them exists here, on a moon nearly 1.5 billion kilometers from the sun. The difference is not in the shape of the world. The difference is only in the material. Swap water for methane. Swap rock for water ice hard as granite. Swap our warm blue sky for a cold orange one, and the physics does the rest, sculpting the same rivers, the same dunes, the same shorelines, the same weather. Titan is not an alien world pretending to be nothing. It is Earth's own logic, running on a different chemistry, at a temperature that would shatter you in seconds. And that is the quiet reversal hidden inside this frozen place. We came here expecting the deadest destination imaginable, and we found the one surface in the entire solar system, apart from our own, where a person could stand on a beach in falling rain and look out at waves. The danger has not gone anywhere. The cold is still there, waiting just beyond the fabric of your suit, patient as the tide. But the loneliness you might have expected, the stare of a barren nothing, is simply not what this world offers. What it offers instead is far stranger, and far more beautiful, and in its own way far more unsettling. Consider what it would mean to move here. On Earth, your body is a prisoner of its own weight, pinned to the ground by a force so constant you stopped noticing it before you could walk. On Titan, that sentence is quietly commuted. The gravity at the surface measures 1.352 meters per second squared, roughly 1/7 of the pull you have felt in every moment of your entire life. A person who weighs 180 pounds on Earth would register the equivalent of about 25 pounds here. You would not float away into the orange dark. Your feet would still find the ground. Yet every stride would carry you further and higher and more slowly than any step you have ever taken, as though the whole world had agreed to let you go. Now, add the air. Titan's atmosphere is not the thin, starved whisper that clings to Mars. It is thicker than the air of Earth itself, pressing on your body with about 45% more force than you feel standing at the edge of the sea. Combine that dense, heavy air with that gentle, forgiving gravity, and you arrive at a consequence that sounds like a fever dream, and is instead only arithmetic. On Titan, a human being could fly, not sealed inside a machine, not lashed to the top of a rocket, but under the power of their own muscles, with a pair of wings fixed to their arms. Here is where belief tends to fail, so here is the mathematics that rebuilds it. On Earth, human-powered flight by flapping is impossible, and it is not impossible because we are weak. It is impossible because our air is too thin and our gravity too strong for the muscles we happen to have. Change both numbers, and the impossibility evaporates. Researchers who ran the calculation found that a person on Titan would need wings covering only about 4.7 square meters, an area smaller than a modest bedroom floor, and a running takeoff of roughly 6 meters per second, little more than a determined jog. That is all. With current materials, with a wing you could carry folded against your back, a suited human on Titan could run a few paces across the dunes and simply leave the ground. Picture it, calmly, the way you would picture a memory. You would not rocket upward. You would rise the way a heavy bird rises, in long, deliberate beats, the languid air holding you up like water holds a swimmer. Below you, the coffee-dark dunes would slide past, ridges of hydrocarbon sand as tall as a 30-story building, carved into long parallel lines by winds you can barely feel at ground level. Ahead, the flat mirror of a methane sea, and all of it lit not by daylight but by a dim amber glow, a light 1,000 times fainter than the noon you know, closer to the last grey minutes of dusk than to any morning. This is the strange gift Titan offers, and it is worth holding on to, because the next thing this world reveals will take it partly away. The seas themselves would deepen the spell. On Earth, the ocean is restless, quick, sharp-edged with white foam. On Titan, the methane moves in slow motion. Waves rise and fall in a heavy, unhurried rhythm, more like oil sloshing in a vast, dark bowl than like surf. The surface lies so glassy and smooth that for years scientists debated whether the seas moved at all, and twice in each long Titan day, which lasts nearly 16 of ours, Saturn's tremendous tidal pull drags the level of those seas up and down by as much as a single meter. A tide that breathes across an ocean of liquid gas. The rain would be gentle here too, and utterly wrong. Methane falls from Titan's clouds not in the fast stinging streaks you know, but in fat, slow droplets that drift down at roughly 1/5 the speed of Earth's rain. You could watch an individual drop descend. You could follow it with your eyes from cloud to ground. It would land on the shoulder of your suit and bead there, colder than anything in human experience, a droplet of fuel falling as weather. Standing on that shore in that falling rain, you would be witnessing a water cycle that uses no water at all, a climate built entirely from the chemistry we burn to heat our homes. And yet, and this is the pivot within the pivot, none of this hospitality is truly hospitality. The beach is real, the rain is real, the flight is real, but the thing that makes flight possible is the same dense, heavy cold that would kill your uncovered body in seconds. The gift and the threat are not two different facts about Titan. They are one fact, seen from two sides. The very thing that could hold you aloft on homemade wings is the atmosphere with no oxygen in it. The gravity that lets you leap like a dream is the gravity that, over years, would leach the calcium from your bones and the strength from your heart. Titan does not offer safety dressed as danger. It offers danger and wonder fused so tightly that you cannot accept one without accepting the other. So the fragile hope is genuine, and it is also a trap for the imagination. It is tempting, standing on that imagined shore, to feel that this world wants us, that a place with beaches and weather and skies you could fly through must somehow be meant for living things. It is a seductive feeling. It is also, almost certainly, false. The kinship you sense is a kinship of physics, not of welcome. The same processes that shaped a coastline you could walk along, shaped it at a temperature that would turn the moisture in your lungs to frost before you finished a single breath. Titan is not Earth's twin. It is Earth's reflection in a black mirror. Every familiar feature preserved, every warmth removed. But there is a reason this reflection matters more than any other frozen rock we have found, and it has nothing to do with the beaches or the dunes or the wings. It has to do with what those falling drops of methane and those slow amber seas might be quietly doing to the chemistry of the surface over spans of time we can barely conceive. Because a world with liquid and organic molecules and energy flowing through it is a world that has satisfied at least some of the conditions we associate with the only phenomenon in the universe stranger than the cold itself. The question is no longer whether a human could stand here. We have answered that. The question is whether anything already does. Consider what this means. To even begin answering that final question, we have to be precise about what life actually requires. Life, as we have only ever known it, needs 3 ingredients we can name without hesitation. It needs a liquid to carry its chemistry from one place to another. It needs a supply of organic molecules to serve as raw material. It also needs a flow of energy to push reactions forward against the pull of stillness. Titan has all 3. It holds more standing liquid on its surface than any world we have ever found except the one beneath your feet. It receives organic molecules drifting down out of the sky in a slow and ceaseless rain, and it carries energy through itself constantly, in the tides, in the wind, in the faint warmth that seeps upward from somewhere far below. This is the unsettling symmetry that keeps a certain kind of scientist awake at night. Not because Titan resembles Earth, but because Titan satisfies the oldest requirements we have for life, while resembling nothing about Earth at all. There are, in truth, two entirely separate places on this single moon where something might already be alive, and they could hardly be more different from one another. The first is the surface. The cold, orange, methane-soaked surface you have been standing on throughout this journey. The second is hidden far beneath it, sealed under a shell of ice, in a place no sunlight has ever reached and no probe has ever touched. Each of these two possibilities is strange. They are strange, however, in opposite directions, and understanding why requires setting aside almost everything your body has taught you about what a living thing needs. Start with the surface, because it is the stranger of the two. Every living cell on Earth is built around liquid water. Water is the stage on which our entire chemistry performs. Titan's surface, though, is far too cold for liquid water. At nearly 291 degrees below zero on the Fahrenheit scale, water on Titan is not a liquid at all. It is stone. It is the bedrock. The pebbles the Huygens probe settled among were not made of mineral rock, but of frozen water, hard as granite and just as permanent. So if anything lives on that surface, it cannot use water as its liquid. It would have to use the only liquid available. It would have to be built around methane. This is not science fiction, though it sounds like it. It is a serious and sober hypothesis that scientists have modelled in careful detail. Life built around liquid methane rather than liquid water would be alien in the deepest sense of the word. Not alien in appearance, alien in its fundamental chemistry. The reactions that sustain such a creature would run agonizingly slowly, because cold thickens chemistry the way a dropping temperature thickens honey until it will barely pour. A methane-based organism might take a year to accomplish what an Earth microbe finishes in a second. It might live for centuries, and think, if it thought at all, in seasons rather than in moments. The honest answer is that nobody knows whether such a thing is possible. The ingredients, however, are all there, sitting on the surface, waiting. Now go beneath the ice. This is the second habitat, and it is the more familiar of the two, which is precisely what makes it so compelling. Somewhere between 55 and 80 kilometers below Titan's frozen surface, sealed under that thick shell of water ice, there is an ocean. A real ocean, made of liquid water, larger than anything on Earth. It stays liquid not because of sunlight, which never reaches it, but because of heat rising from the moon's interior and the flexing pull of Saturn's enormous gravity. Down there, the temperature is not 290 degrees below zero. Down there, water flows. Where liquid water flows in the dark, Earth has taught us to expect the possibility of life. Hold those two images side by side for a moment. Titan is not one candidate for life. It is two candidates stacked one atop the other, sharing nothing but a name. On the surface, a chemistry so cold and so slow, it would redefine what the word living even means. In the depths, an ocean so ordinary in its ingredients that it could almost be a slice of our own seafloor, buried under dozens of miles of ice. Not one frontier, but two. Not one impossible question, but two impossible questions, resting on the same small moon in the outer dark. The machine that feeds all of this never rests. There is a cycle on Titan much like the water cycle on Earth, except that it runs on methane instead of water. Methane evaporates from the seas, gathers into clouds, and falls again as rain. This rain, though, does not fall the way Earth rain falls. In gravity 1/7 as strong as our own, the drops swell larger and drift downward at roughly 1/5 the speed, so slowly that you could watch a single droplet descend the way you might watch a feather settle through still air. That rain feeds rivers. Those rivers carve channels into the ice and carry dissolved organics down toward the seas. The seas themselves rise and fall, breathing in and out by as much as a full meter over the course of a single Titan day, which lasts nearly 16 of our own, as Saturn's gravity drags the liquid back and forth across the basins. Every part of this cycle moves chemistry from one place to another. Every part of it mixes, concentrates, and reacts. To grasp how much liquid is involved, consider the largest of these seas. Kraken Mare covers roughly 500,000 square kilometers, an expanse larger than the Caspian Sea, and something close to 5 times the size of Lake Superior. In August of the year 2014, the Cassini spacecraft swept over it, firing radar down from an altitude of 970 kilometers while traveling at 21,000 kilometers per hour, and it measured the echoes that came back. In the central basin, the radar could not find a bottom above 300 meters, nearly 1,000 feet of liquid methane and ethane, dark and cold and utterly still, sitting on the surface of a moon most people will never once think about. This is not a puddle. It is a reservoir of raw chemistry deeper than most of the lakes on Earth, and it has been sitting there reacting for longer than our spaces has had a name for the sky. Here the true weight of Titan begins to press down, because chemistry does not happen in an instant, it happens over time. Titan has had almost unimaginable amounts of time. The organic rain that dusts its surface has been falling for as long as the moon itself has existed. Every methane molecule split apart by sunlight in the upper atmosphere becomes part of a larger molecule, and that molecule drifts down and joins the sand, the dunes, the lake beds. Layer upon layer upon layer. The tholins that paint the sky its permanent shade of dark orange are only the visible edge of a chemical factory that has been running without pause since before the first living cell ever appeared on Earth. Here is the hidden truth that everyday experience conceals. We think of cold as a kind of stopping. We open a freezer, and the food inside seems suspended, unchanging, held motionless in time. Cold does not stop chemistry though, it only slows it. Every reaction that can happen still happens, just more and more reluctantly as the temperature falls. Give a slow reaction enough time, and it becomes not merely possible but inevitable. Not a century, not 1,000 centuries, not 1,000,000. Across the vast and patient reach of deep time, even chemistry that would appear frozen solid to a human watching for an entire lifetime still creeps forward, one reluctant bond at a time. These calculations reveal a profound truth that chemistry encodes but everyday experience obscures. Time and temperature are not two separate things, they are a single lever, and what one takes away, the other can slowly give back. So the surface of Titan is not the sterile frozen graveyard it appears to be. It may be something far stranger. A laboratory that has been quietly assembling the building blocks of life for an almost unthinkable span of years, in the dark, in the cold, entirely without an audience. Not building life, perhaps, but building the pieces from which life, on at least one other world, was eventually assembled. Everything you would need to run the experiment that produced you is present on Titan, spread across its dunes and dissolved in its seas. The only ingredient in short supply is warmth. The only witness, so far, has been a single probe that lasted 54 minutes. This is why humanity is going back. In the year 2028, if the schedule holds, a nuclear-powered rotorcraft the size of a small car, carrying 8 rotors, will lift off from Earth and begin the long fall towards Saturn. Its name is Dragonfly, and it will not reach Titan until the year 2034, after a journey of roughly 6 years across more than 1 billion kilometers of empty space. When it arrives, it will do something no machine has ever done anywhere beyond Earth. It will fly. Under Titan's thick air and gentle gravity, it will lift off again and again, hopping from site to site across dozens of locations, covering several hundred kilometers over the course of 3.3 years. It will settle onto the dunes. It will sample the organic sand. It will taste the chemistry that has been gathering there in the dark since long before anyone was alive to wonder about it. Consider what this means for the question we have been circling. Every measurement Dragonfly makes will be a measurement of deep time made visible. The molecules it finds in that sand will be a record, layer by patient layer, of an almost unthinkable span of years of chemistry running at a pace no human could ever hope to watch. We will not be reading a snapshot, we will be reading a history. The terrible and beautiful possibility hidden inside that history is that somewhere in the sequence, on the surface or in the sea, the chemistry did not merely grow more complex, It crossed a line. It began, however faintly, to do the one thing that separates the living from the merely intricate. It began to copy itself. To copy itself is the oldest and strangest trick anything in this universe has ever learned. A molecule that can gather the loose pieces drifting around it and assemble a rough duplicate of itself has crossed a boundary that no amount of mere complexity can reach on its own. This is not a difference of degree, it is a difference of kind. A snowflake is intricate, but a snowflake cannot make another snowflake. A tholin, one of those complex organic haze particles that stain Titan's sky the color of old rust, is intricate too. But somewhere in the long dark, in the sand or in the sea, that intricacy may have stumbled onto the trick, and if it did, it had almost unlimited time to practice. Consider what deep time actually means in a place like this. On Earth, chemistry runs warm and fast. The reactions that stitch together the molecules of life happen in seconds, in minutes, in the space of a single quiet afternoon. On Titan, at nearly 291 degrees below 0 Fahrenheit, chemistry crawls. Every reaction that would flash to completion in a warm laboratory instead unfolds across spans of time that dwarf any human patience. But Titan has never been in a hurry. It has had billions of years, and it spends them the way a glacier spends a winter, one imperceptible motion at a time. Now stack the numbers and let them fall. Not 1,000 years of this slow and secret chemistry, not 1,000,000, not 100 million. Titan has been brewing its orange haze, dropping it onto the surface, and washing it into the seas for a stretch of time, longer than complex life has existed on Earth at all. The sand that Dragonfly will taste in the year 2034 is not fresh. It is the residue of an experiment that has been running, unattended and unhurried, since long before the first creature ever crawled from an ocean onto a shore. We will not be sampling a moment, we will be sampling an inheritance, and the surface is only the visible half of the story. Beneath Titan's icy crust, somewhere between 55 and 80 kilometers down, there is an ocean. Not an ocean of methane like the glassy seas that catch the dim light above. An ocean of liquid water, kept from freezing by the slow heat of the moon's interior and the relentless tidal kneading of Saturn's gravity. This distinction matters enormously, because liquid water is the one ingredient that every living thing we have ever found has required. Titan, then, is not one possible cradle, it is two. A frigid organic laboratory spread across the surface, and a dark, warm sea buried far below, separated from each other by tens of kilometers of solid ice and by hundreds of millions of years of undisturbed chemistry. This is what everyday experience hides from us. We look at a cold, dark, distant moon, and our intuition files it away as dead. Empty. Finished. But the physics tells a different story, and the physics does not care what our intuition expects. The cold does not stop the chemistry, it only slows it. The darkness does not sterilize the sand, it only hides what the sand has been doing. And the slowness that would exhaust any human observer is, for a world with billions of years to spend, no obstacle at all. What looks to us like death may simply be life running at a tempo we are too short-lived to perceive. Consider what this means for a human being standing on that surface, sealed inside a suit, breathing carried oxygen. You would be standing on the roof of a hidden ocean you could never reach, above the possibility of a biology you could never touch, in a light 1,000 times dimmer than the noon you were born under. The sunlight falling across your visor would be old light. It would have left the sun roughly 80 minutes earlier. On Earth, that same journey takes only about 8 minutes, not slightly farther from home, 10 times farther from the warmth that made you, out where the sun is 100 times fainter, and Saturn hangs across a gulf of nearly 1.4 billion kilometers. And the distance is not only measured in kilometers, it is measured in years. The fastest we have ever crossed that gap took roughly 7 years of continuous travel, a spacecraft falling silently outward through the dark for longer than a child takes to learn to read. To stand on Titan is to accept that the world that made you is 7 years behind you in every direction. No rescue could arrive in time to matter. No message could cross the distance and return within a human afternoon. The isolation is not psychological. It is written into the geometry of the solar system, and no amount of courage can shorten it. Now let the deep time turn its attention on the human body. In that gentle gravity, roughly 1/7 of Earth's, the very thing that would let you leap and glide and even fly would also, slowly and quietly, take you apart. Bone that is never asked to bear weight begins to dissolve away its own mineral. Muscle that is never truly worked begins to waste. The immune system itself grows uncertain and weak in a body that no longer feels the steady, honest pull of the ground it evolved under. This is not the sudden violence of the cold or the fast mathematics of asphyxiation. It is the opposite. It is erosion. It is deep time performed on flesh. The same patient wearing down that carved Titan's dunes, turned now upon the person standing among them. And here is the quiet horror the mathematics encodes and everyday experience obscures. Everything that makes Titan survivable is also, given enough time, a form of slow subtraction. The thin pull of gravity that spares your suit its weight is the same pull that thins your bones. The unhurried chemistry that may have birthed something alive is the same unhurried tempo that would grind a colony down across generations. The stillness is not safety. The stillness is patience. And patience, at the scale Titan works in, is simply another word for inevitability. So the terrible symmetry comes into focus. Deep time might have written life into the sand beneath your boots, and deep time would just as surely write your own unraveling into your marrow. The same billions of years that make Titan one of the most compelling places in the entire solar system to search for a second Genesis are the years that make it one of the least forgiving places for a creature built and calibrated for Earth. You would be a fast, warm, fragile thing standing in a slow, cold, and enormously patient world. It would not need to attack you. It would only need to wait. And yet, hidden inside that patience, there is one more layer we have not yet touched. Because the question was never only whether a human could survive on Titan for a season, or a year, or a lifetime. The deeper question, the one that waits underneath all the others, is what it would cost to survive there long enough to matter, long enough to change, long enough to become something the Earth that launched you would no longer entirely recognize. That transformation would not be a matter of the mind alone. It would be written into the body itself, quietly, one cell at a time, by the single force on Titan that never rests and never relents. Titan pulls on everything standing upon it with an acceleration of 1.352 meters per second. That is roughly 1/7 of the gravity you are assembled to live inside. A person who weighs 180 pounds on Earth would register something closer to 25 upon Titan's frozen ground. Your first step would carry you farther than you intended. Your first stumble would fall in gentle, dreamlike slowness, as though the whole world had agreed to be kind. And that gentleness is precisely the trap, because the danger of low gravity is not that it hurts you, it is that it does not. Every muscle in your body, every strand of bone, was shaped across millions of years by a single unspoken assumption that there would always be weight to push against. Your skeleton is not a fixed scaffold, it is a living negotiation, constantly torn down and rebuilt in response to the loads it carries. Take away the load, and the negotiation tilts. The body, sensing that its bones are no longer needed at full strength, begins, with perfect biological logic, to dismantle them. This is the quiet arithmetic of surviving on Titan long enough to matter. At 0.138 of a single Earth gravity, the human frame does not break in an afternoon. It erodes across seasons, bone density falls, muscle fibers thin and shorten. The immune system, that vast and vigilant internal army, grows sluggish and less watchful, as though it too had decided the fight was no longer worth the effort. These are not exotic Titan diseases. They are the familiar afflictions of every astronaut who has ever spent long months in orbit, only slowed and stretched and made permanent by a place where you might live not for months, but for years. Consider what this means. Mars, so often imagined as the great proving ground of human endurance, offers roughly 0.38 of Earth's gravity. That is a little more than a third. It is punishing, but it is a fraction of Earth that the body can at least partly recognize. Titan offers less than half of even that. A colonist on Titan would live in a gravitational field weaker than the one on the surface of our own moon. And the cruel truth is that the risks do not simply scale in proportion. Less gravity does not mean slightly more bone loss. It may mean that the body, given so little to resist, unravels further and faster than anything our medicine has yet learned to hold together. So the survivors of Titan would not be the ones who defeated the cold or outwitted the darkness. Those problems we have already seen are problems of engineering, and engineering can be solved with enough oxygen, enough insulation, enough patience. Not the cold then, and not the airlessness, but gravity itself would become the final adversary. Not a killer that strikes, but a sculptor that reshapes. It would work on you the way wind works on the hydrocarbon dunes, invisibly, tirelessly, grain by grain, until the shape it leaves behind is no longer the shape that arrived. To hold that shape, a long-term resident would have to fight the world every single day. The countermeasures are not mysterious. They are exercise, relentless and scheduled and unforgiving. Hours of it, forcing the muscles to strain against loads that Titan itself refuses to provide. They are weighted clothing, garments deliberately made heavy so that the body is fooled into believing it still carries the burden of Earth. Imagine building an entire civilization whose citizens must wear artificial weight simply to keep their own skeletons from quietly disappearing beneath them. Imagine that this is not an emergency, but the ordinary condition of a life lived far from home. You would spend your days pretending to be heavy, because the alternative is to slowly stop being able to stand at all. And here, in the middle of that slow unraveling, Titan offers something almost unbearably beautiful. Something no other surface in the solar system can give. Because that same weak gravity, the very force that thins your bones and steals your strength, also hands you a gift that no human being has ever possessed on their own world. On Titan, a person could fly, not fly in the sense of falling slowly, and not fly in the sense of a machine carrying you aloft. Fly the way a bird flies, under the power of your own body. The combination is unique in all the places we know. Titan's gravity is barely more than 1/10 of Earth's, and its atmosphere is dense, thicker at the surface than the air you are breathing right now. Thin gravity and heavy air are exactly the two ingredients that human flight has always lacked. Researchers have run the numbers with sober precision. A person equipped with a set of wings offering a surface area of only 4.7 square meters and able to reach a running takeoff speed of just 6 meters per second could lift clear of the ground and stay airborne. 6 meters per second is a brisk jog. 4.7 square meters is a wing you could imagine strapping to your back. Sit with that image for a moment. A human being, sealed inside a suit against the cold, breathing bottled oxygen, could take a short running start across an alien beach of dark hydrocarbon sand, spread a pair of wings, and simply rise into a sky the color of old rust. No engine, no fuel, only muscle and air and the mercy of a world too small to hold you down. Beneath you, the glassy black surface of a methane sea would slide past in dreamlike silence. Above you, the haze would glow that dim and endless orange, and you would be doing, with your own arms and your own breath, the one thing our entire species has dreamed of since the first human looked up and envied the birds. But the gift and the wound come from the same hand. This is the layer beneath the layer, the truth that waits under the wonder. The gravity that lets you fly is the gravity that is dissolving you. The lightness that turns you into a creature of the air is the same lightness, slowly hollowing your bones toward the day when you could not survive a return to the world that made you. You might soar across Kraken Mare like something out of a myth, and in the same season your body might be crossing a threshold from which there is no coming back. To become a flyer on Titan, you would have to consent, whether you meant to or not, to becoming something that Earth can no longer entirely hold. That is the final layer of the survival question, and it is the one that has almost nothing to do with equipment. The cold, the airlessness, the pressure, the dunes, the long dark, all of these we could survive, given enough ingenuity and enough will. The thing we might not survive is the changing itself. The way a place remakes the creature that lives in it. The quiet certainty that to endure on Titan long enough to build anything, to raise anything, to belong to it in any real way, you would be traded piece by piece for a version of yourself the launching world would no longer recognize as fully its own. And we should be honest about how far away all of this still is. We speak of colonists and flyers and lifetimes on Titan, and yet we have never landed a single human being anywhere beyond our own moon. We have placed exactly one machine on Titan's surface in the entire history of our species, and it fell silent after less than an hour. The journey alone is a barrier that dwarfs every suit and every wing. Cassini and Huygens launched from Earth on the 15th of October, 1997, and did not reach Saturn until the 1st of July, 2004, a crossing of 6 years and 8.5 months through the empty dark. A one-way trip to Titan takes the better part of a decade. A creature already unraveling in low gravity would have to spend years unraveling in the near weightlessness of the voyage before it even arrived. Our next step toward that world is not a colony, and it is not a human being. It is a car-sized machine with 8 rotors, a nuclear-powered flying laboratory named Dragonfly, built at a cost of $3.35 billion. It is scheduled to launch in July of 2028 and to reach Titan in 2034, and when it does, it will become the first aircraft ever flown on the natural satellite of another world. Over 3.3 years it will hop between dozens of landing sites, crossing several hundred kilometers of dune and shoreline, doing with rotors what a distant future human might one day do with wings. It is a scout sent ahead into a world we have barely begun to understand. A world beneath which, 55 to 80 kilometers down through the ice, an entire hidden ocean of liquid water waits in the dark, older and deeper than any question we have thought to ask of it. So we arrive, at last, at the edge of the only question that truly remains. We have measured the cold and named the killers. We have built the suit and calculated the wing. We have counted the years of the voyage and the erosion of the bones. We have learned, in the end, that a human could survive on Titan, not easily and not without cost, but genuinely, for a season or a lifetime if only they were willing to be changed by it. And that willingness is not a matter of physics at all. It is a matter of something older and less measurable, something no instrument aboard Huygens was ever built to record. A person who travels to Titan does not simply visit it. They give something up on the way there, and they give up more with every season they choose to remain. To understand what that surrender truly costs, we have to look one final time at Titan not as a surface a person stands upon, but as a stack of worlds layered one atop another, each stranger than the one above it. Begin at the very top, 600 kilometers overhead, 10 times higher than the thin skin of air that wraps our own planet. Titan's atmosphere finally thins away into the dark of space. The haze that gives the sky its color of old rust is not merely a curtain hanging over the world. It is a machine. It does not warm the moon the way carbon dioxide warms the earth. It does something far rarer. The haze reflects a great deal of the faint sunlight straight back into space before that light can ever reach the ground, while the methane nearer the surface traps a little of the warmth that survives the journey down. An anti-greenhouse effect above, and a weak greenhouse effect below, two opposing forces locked in balance, holding the surface at its steady and merciless cold, descend through that haze, and the light fades into something a human eye would struggle even to name. Sunlight reaches Titan roughly 100 times fainter than the light that falls on Earth, and it has travelled for about 80 minutes to arrive, against the 8 minutes it needs to reach us. By the time that already feeble light has filtered down through 600 kilometers of orange smog, the brightest noon on Titan is dimmer than a deeply overcast evening back home. You would spend your entire stay inside that unbroken amber twilight. Not true darkness, something quieter and stranger than darkness. Because it never fully becomes night, and it never quite becomes day. Then comes the surface we have already walked across in our imagination. The dunes of hydrocarbon sand, the pebbles of dirty water ice, the glassy methane seas lying flat and patient under the dim sky. But the surface is not the bottom of this world. It is only the floor of the part you are able to see. Beneath it waits the final layer, and it is the most astonishing of them all. Far below even the deepest methane sea, through a shell of ice that is as hard as rock at that temperature, there is water. Not methane, not ethane. Liquid water, a vast buried ocean of it, lightless and sealed and older than the very question of whether anything could ever live within it. This is the layer that changes the entire reason we go, not because a human could survive on the frozen surface above it, though we have shown across these long hours that a human could. We go because beneath that surface, hidden in the permanent dark, sits one of the most promising places in the whole solar system to search for life that did not begin on Earth. And here, at the deepest layer of all, the final hope and the final dread meet, and they refuse to be separated. The hope is almost too large to hold. An entire ocean, wrapped in organic chemistry, stirring slowly beneath a crust of ice on a world where it rains a slow fuel from an orange sky. If life were ever going to arise a second time within a single solar system, this buried sea is among the likeliest places it could have happened. But the dread is quieter, and it sits much closer to the skin, because to reach down toward that ocean, someone would have to stay. And Titan does not allow its guests to remain unchanged. The gravity is the thief. At a pull of roughly 1/7 of Earth's, at a gravity even gentler than the Moon's, the human body slowly begins to forget how to be a body at all. It does not happen in a single day, and it does not happen in a week. It happens quietly, across the long months. The bones grow thin as their mineral quietly drains away. The muscles waste and soften with disuse. The immune system, which evolved under a weight the frame no longer feels, grows uncertain and sluggish and slow to answer a threat. Mars, at more than 1/3 of Earth's gravity, would be kinder to the skeleton than this. A colonist on Titan would have to fight that silent erosion during every waking hour, with exercise that never truly ends, and with weighted clothing worn almost like a penance, trading away comfort for the simple hope of one day standing up straight again on a heavier world. So this is the tiny hope, and this is the new dread, and they are held together in the same cold hand. An ocean that might harbour life, sealed away under 50 and more kilometers of ice we would almost certainly never breach. A surface a person could survive upon, at the slow and steady price of their own thinning bones. Every layer of this world offers something, and takes something in the very same breath. We began, hours ago, with a single number, a temperature nearly 291 degrees below zero, measured by a probe that fell silent after 54 minutes on the loose wet sand. And we have followed that number all the way down through the haze and the machine that makes it, down through the amber twilight that is neither night nor day, past the dunes and the languid methane seas, into the buried ocean, and back up again into the fragile arithmetic of a human trying to stay alive in the middle of all of it. We have learned that the cold can be defeated with insulation, that the darkness can be endured, that the missing oxygen can simply be carried in on the back, that even the bones can be braced, for a while against the gentle pull that would slowly waste them. Every physical obstacle, taken one at a time, has yielded to an answer. Not an easy answer, not a cheap one, but an answer all the same. And so we arrive at the end of all the physics, at the one obstacle that has no equation waiting to solve it. Not whether a human being could survive on Titan, because by now we know, past any real doubt, that they could. but whether a human being should, whether the price this world quietly demands, the 7 years of travel, the immense and lonely distance, the slow unmaking of the body, the amber light that never once softens into morning, is a price worth paying for a single scout's glimpse of an ocean we may reach out toward for centuries and never once touch. That word, should, is where the physics finally goes quiet. Every question before it carried an answer somewhere inside it, buried in a measurement, a material, a thin margin of survival time. This one does not. No instrument aboard any probe can measure whether a thing is worth doing. No equation returns a value for meaning. And so, having spent all this time learning exactly how a human body would live and die beneath that amber sky, we arrive holding the one question Titan itself cannot answer. Not the question of survival, the question of why. Consider what this means. We have proven, past any honest doubt, that a person could stand on that frozen shore and breathe and think and look out across a sea of liquid methane the size of a small ocean. The cold yields to insulation. The missing oxygen rides in on the back. The long fall of the bones can be braced against, at least for a while. Every wall has a door in it, and yet the moment all the walls come down, a stranger and quieter obstacle rises in their place, and it is made not of temperature or pressure, but of judgment. Whether the doing is worth the cost. Perhaps it is. Perhaps a human being belongs anywhere a human being can reach, and the reaching is its own justification, needing no defense beyond the fact that it can be done. Perhaps the 7 years of travel, the immense and lonely distance, the slow unmaking of the body in gravity barely 1/7 of our own, would all be repaid in a single hour of standing where no living thing has ever stood. Perhaps the first person to press a boot into that loose wet sand, into the same soft ground the Huygens probe touched and studied for 54 minutes before its voice went silent, would feel in that instant that every sacrifice had been small. Or perhaps not. Perhaps the human spirit needs the morning more than it needs the frontier. Perhaps a mind can endure the cold and the dark and the crushing distance, and still be quietly broken by a sky that never once softens into dawn. An unbroken orange dusk that holds steady through every waking hour of a life spent far from home. Both of these can be true at once. That is the strange arithmetic of the question. The same journey that would fulfill one person entirely would hollow out another, and no measurement taken on the surface could ever tell you in advance which kind of person you would turn out to be. The danger of Titan is not hidden. We can list it, line by line. The temperature near 290 degrees below zero on the Fahrenheit scale. The air with no breath of oxygen in it. The light 1,000 times dimmer than an Earth noon. These are known quantities. They can be planned around. But the weight of permanent exile, the private cost of a place where the sun is 100 times fainter and takes 80 minutes simply to arrive, is not a known quantity. It is different for every heart that would carry it. This distinction matters enormously, because it moves the whole question out of the laboratory and into somewhere far harder to reach. Engineering can tell you the thickness of insulation a suit requires. It cannot tell you how a person will feel in the 9th year of a life lived under haze. Medicine can measure the bone density lost month by month, the muscle that thins, the immune system that slowly weakens in that gentle pull. It cannot measure whether the view was worth the wasting. These are not failures of science. They are simply the edge of what science was ever built to do. Beyond that edge, the only instrument left is a human being, deciding. And here is where the question has to be handed back. Not to the physicists who mapped the cold. Not to the engineers who will one day build the suit that defeats it. These questions have no universal answers, and pretending otherwise would be its own kind of dishonesty. Different people will make different choices, and each of them will be right in their own accounting. There will be some for whom the very indifference of that world is the draw, who would trade a lifetime of ordinary mornings for one unrepeatable strangeness. There will be others, just as brave, just as curious, who would read every fact in this account and know with total certainty that their place is here, under a sun that rises, on ground that was made for the shape of us. Neither of them is mistaken. The question was never going to sort people into the wise and the foolish. It only reveals what each of us already values, when the choice is finally made real. So set aside, for a moment, the person who might one day go. Consider instead the far larger number of us who never will, and yet who are changed simply by knowing the place exists. Because this is the quiet gift, buried inside the whole grim inventory of survival times and killing temperatures. You do not have to travel to Titan to be moved by it. You do not have to risk the cold to feel the strange comfort of learning that somewhere, right now, in this same present moment, a sea of liquid methane is lapping in slow and languid waves against a shore of frozen organic sand, in a light the colour of old rust, and no eye is there to see it. It is happening whether we come or not. It was happening for the billions of years before anyone on this world knew the moon had a name, before Christian Huygens first caught it as a fleck of light beside Saturn. It will go on happening long after the question of whether to visit has been answered, one way or the other, and forgotten. That is the reframe that matters more than any survival ladder. Not how long a human could last on Titan, but how small a human is against it, and how strangely bearable that smallness turns out to feel. We spend so much of this account measuring the moon against ourselves, whether its cold would take us in seconds or in hours, whether its air would let us live or stop us in 15 seconds flat, whether its gravity would carry us aloft on a wing of 4.5 square meters, or slowly waste the bones that keep us upright. Every one of those measurements uses the human body as its ruler, and there is something almost unbearably humbling in stepping back far enough to see that Titan does not know we are measuring it. It does not know we are here. It is never known. Understanding this requires dismantling something we rarely say out loud, which is the quiet assumption that a place matters, because we might one day use it. Titan does not need us in order to be extraordinary. Beneath its icy crust, somewhere between 55 and 80 kilometers down, lies an ocean of liquid water larger than anything on the surface of our own world, sealed in the dark, untouched by any light at all. Whether anything lives in that hidden sea, we do not know. The honest answer is that nobody knows, but the very possibility, the faint and patient chance that the chemistry of this frozen moon has been quietly assembling something alive across the long ages, makes Titan one of the most compelling places in the entire solar system to point our questions toward. Not because we could survive there, but because something else, something not us, might already have found a way. That is a different kind of reaching than the one we began with. The first reaching was outward, the human hand extended across the distance, asking how long the body could endure. This second reaching is quieter and stranger. It asks not what we could take from Titan, but what Titan might have to tell us about how rare, or how common, the thing called life truly is. And that question does not require a single human boot on the surface to begin answering it. It requires only that we keep sending our patient machines. A car-sized rotorcraft named Dragonfly, nuclear-powered and built to fly through that thick cold air, is scheduled to lift off from Earth in the year 2028 and to arrive, after another journey of roughly 6 years, in the year 2034. It will be the first aircraft ever flown on the moon of another world. It will travel to dozens of sites across more than 3 years, covering several hundred kilometers of terrain no human eye has ever seen up close. And it will carry no one at all. There is a lesson folded into that emptiness. The most likely way humanity first comes to know Titan intimately is not through the body but through the instrument, not through survival but through patience, not by sending a person to endure the cold, but by sending a machine that feels nothing and needs nothing, and simply looks. The question that has carried this entire journey, how long a human could survive down there, may turn out to be, in the end, the wrong question entirely. Not wrong because the answer does not matter. It matters enormously to anyone who might one day make the crossing, but wrong because it quietly assumes that presence is the point. that a place is only truly reached when a person stands upon it. Titan invites a humbler idea, that we might come to know a world completely and love it in the strange way we love things too vast and cold to hold, without ever setting a single fragile body down upon its frozen ground. Perhaps that is enough. Perhaps to map every dune and sound every sea, to watch the methane rain fall in its slow enormous drops and understand exactly why it falls that way, is a form of arrival that asks nothing of the body at all. Or perhaps something in us will never accept knowledge as a substitute for footprints. Perhaps the human spirit requires the crossing more than it requires the answer, requires the risk more than the safety, requires to stand inside the orange dark and feel that near 290 degrees of cold pressing against the thin wall of a suit, and know, in the animal way that no instrument can know, that it is truly there. These questions have no universal answers. Different people in different centuries will make different choices. Some will look at the 7 years of travel, the bone loss, the muscle that wastes in 1/7 gravity, the 2 minutes you would have before the airless cold finished what the missing oxygen began, and they will decide that a machine is the wiser ambassador. Others will look at the same facts and hear an invitation. Neither is wrong. The choice belongs to no expert and no author. It belongs to whoever is listening, and to the ones who come after them, and to a future none of us will live to see. So consider, one last time, the shape of the thing. A moon larger than the planet Mercury, wrapped in an atmosphere 10 times taller than our own, lit by a sun so distant its warmth takes 80 minutes to arrive, and lands 100 times fainter than the light you know. Beneath its frozen crust, 50 to 80 kilometers down, an ocean of liquid water waits in the dark, older than any question we have thought to ask of it. Above that hidden sea, methane falls as rain and pools as glassy black lakes, and the wind builds dunes of organic sand 100 meters tall, and none of it needs us. It has been doing this for billions of years. It will do it for billions more, whether or not a single human eye ever looks upon it directly. And yet, we are looking. That is the quiet miracle folded inside all this cold. On a warm blue world more than 1 billion kilometers away, a species that evolved to fear the dark has built machines to fall through an alien sky and touch a shore no living thing has ever walked. In the summer of 2028, another one will leave the ground. 6 years later it will spread 8 rotors in that thick orange air and fly, the first aircraft ever to lift off from the surface of another world's moon. We may never send a body, we may never need to, but we will keep sending our attention, our patience, our stubborn wish to understand. And in that reaching there is a kind of presence that no distance and no cold has ever managed to stop. The universe does not care whether we come. It offers no welcome and holds no grudge. Titan will keep its temperature near 94 Kelvin, and its seas will keep their slow dark tides long after the last human question has been asked and forgotten. This is not a reason for despair. It is closer to a kind of freedom. In a cosmos that demands nothing of us, everything we choose to do carries only the meaning we are willing to give it, and the wish to know a frozen moon 1 billion kilometers away is as pure a meaning as any we have ever invented. So we will keep looking outward, into that patient dark, toward the one strange shore where the rain falls slow and the pressure alone would never kill us. The cold